Hello everyone. In this session, I'd like to explain the resistors in series and parallel. Left figure shows the series connections of the two resistors, and right figure is a parallel connection of the two resistors. First of all, we'd like to consider the resistors in series connections. Current is flowing to resistors. The same current is flowing to the two resistors, but voltage drop depending on the resistance of each resistor. So voltage drop V sub 1 is expressed I current times R sub 1 is resistance. Voltage drop of the V sub 2 is I times R sub 2. Sum of the two voltage drop is equal to the V, total voltage. V equal V sub 1 plus V sub 2 is equal to I times R sub 1 plus R sub 2. So we could consider the equivalent resistors is a V equal I times R sub equivalent. So R sub equivalent you could compare with these two. R sub equivalent is equal to the sum of the R sub 1 plus R sub 2. This is the case of the series connections. In the case of the parallel connections, current is divided into the two flows. For each resistor has the same voltage drop of the V. So I sub 1 is equal to, you can use a V equal I sub 1 R sub 1. The V equal I sub 2 R sub 2. So you can find the I sub 1 is a V over R sub 1. So you can find the I sub 1. And the I sub 2 equal V over R sub 2. I sub 2. You can substitute. Then total current of the I is equal to the I sub 1 plus I sub 2 equal V over R sub 1 plus V over R sub 2. And if you consider equivalent resistors, V equal I times R sub eq. So this means I over V equal 1 over R sub equivalent. Also, you can use this equation to find the I over V. 1 over R sub 1 plus 1 over R sub 2. Then you could compare these two equations. Then find out 1 over R sub equivalent is equal to 1 over R sub 1 plus 1 over R sub 2. This is the case of the resistors in parallel connections. The next topic is the powers. So current is flowing inside of the resistors and the energy is consumed inside of the resistors. And we would like to find out how much energy is consumed inside of the resistors. Work done in the resistors can be calculated. Force times the distance. This is a force acting on the charge of the dq. This is charge of the dq. Is acting force is the dq times the electric field of E. Force times the distance. To find the total work done on the charge. ED is equal to the voltage drop with the V. So this equation is the dq times the V. Then if you multiply the dt and divide the dt, the dq over dt times dt times the V. So dq over dt is equal to the current I. So this equation is expressed IV times dt. So power P is expressed dW over dt. Using this equation, power can be expressed product of the current times the voltage of V. And the unit of the power is joule per second is equal to the watt. You can find out the current flowing in the electric device in your house, power distribution systems. So for example, a 100 watt light bulb you could consider in the house in Japan, the voltage drop is a 100 volt. You can use the P equal IV. Using this equation, I equal P power divided the voltage. So power is a 100 watt light bulb divided 100 volt. So current flowing inside of the 100 watt light bulb is a 1 ampere. Using the V equal IR, you can find the resistance inside of the light bulb can be calculated. V equal 100 volt, and the current is 1 ampere, and the resistance becomes 100 ohm. So using these equations, you can find the resistance and also the current flowing in each electric device. For example, in the case of the microwave ovens, 1450 watt microwave ovens divided by the 100 volt, it becomes, you can find the current flowing microwave oven to be the 14.5 ampere. Rice cookers 10.15 ampere. Electric toaster is 10 amperes. Electric carpet is 5.8 ampere. TV is 0.51 ampere. DVD players is 0.37 amperes. Then what happens if you turn on all the electric devices at the same times? Maybe you might have a same experience with me. Actually, you cannot use any device in your house because the breaker downs. Then you might hate the breakers. Don't get angry to the breakers. Actually, breaker try to protect you. So if you consider the wire with a 2 millimeter diameter is able to carry the maximum current of the 20 amperes. If the wire try to carry the more than 20 amperes of the current, then temperature of the wire becomes too high. Then wire might be melted. To stop such an accident, actually the breaker or fuse protect the overloading and overheating of the wires. Okay, this is the end of the second session.